Hi friends, in arithmetic ability we'll see the topic HCF and LCM. So this complete topic I'll explain you now. So just before going to discuss this HCF and LCM, you must know some important points or some key points. So we should know about the factor and common factor, multiple and common multiple. Fine. So we must know these simple basics first. Then it's easy to understand HCF and LCM. And based on HCF and LCM, I'll explain you all the different type of questions which will come for any competitive exams. I'll show you one paper. So after discussing the complete topic, so I'll explain you this one of the model paper also. So in this example paper, one is example paper. Let us discuss like the even word problems and some practice exercise too. Some exercises are there, practice exercise 2, exercise 1, which will be helpful for any type of exams. So there is no other questions HCF and LCM apart from which I am discussing here. Not only this, some other topics also you can see in this particular website. You can see here this foundation for IIT.com. So in this any competitive examination point of view questions, at the same time any board, so this is channel and this website, these both are completely for educational type of videos and educational concern material only is available. So you subscribe this channel, at the same time you go to this website, and complete information is free of cost including material. So you can read that material and you can see the videos. Fine. Okay, we'll start the topic now. First of all, the factor and common factor. It is a natural number which exactly divides the given number. This is definition for factor. Factor of, okay, factors of, if you take 8, now a natural number which exactly divides the given number. Now what are the, in which tables the 8 is there? For example 1. 1 8 is 8. So 1 is a factor of 8. Then in 2 table, like so if we divide with 2 we'll get remainder 0. There exactly divides. Now 3, because 3 is not in 8 table. Again 3 table, it is not there, so 3 is not a factor. Then 4, because 4 2 is 8. Then 5 6 7 are not. Then 8. Okay. 1 2 4 8 are the factors of 8. Okay, factors of one more number. Let us take 15. So which are the numbers exactly divides this 15? Exactly divides. That means remainder should be 0. Now 1. So 1 is the common factor for any number. 1 is compulsory because in one table everything is there. Then 3, 5, because 5 3s are and 3 5s. Then next is 15. So 1 and itself, they are the compulsory factors apart from remaining numbers also which are divisible. So these are the factors. Now common factors. So just the word itself it denotes, it says the common. Now in the factors which is common, that we can take it as a common factors. A number as, so okay, now in this 8 and 15 the common factor is only 1. So 1 is here and 1 is here. So only 1 is the common factor. Now common factor of 8 and 15 is 1. So only 1 is the common factor of 8 and 15. Let us take one more example. Okay. Factors of 6 and factors of same 15 I am taking. Okay, factors of 6 are, so which are perfectly divided 6 is 1, 2, 3 and 6. And for 15, as we discussed previous, 1, 3, 5, 15. So in this the commons are 1 and 3. So 1 is here and here, so 1 is the common factor and 3 also common factor. Now common factors of 6 and 15 are 1, 3. Now these are the common factors. Now let us see the multiple and common multiple first. Then we'll go for the topic HCF and LCM. Now let us take the multiple. When a number is multiplied by 1, 2, 3, so on, the products obtained are known as the multiple of that numbers. So for example, if you take multiple of 2, so we can take in this, which is multiplied by 1, 2, 3. Now 2 ones are 2 and 2 twos are 4, 2 threes are 6, 8, so on. These are all the multiples of 2. Multiple of 3, 4. Multiple of 3 is in 3 table. That is 3, 6, 9, 12, 15 and so on. Now in this 2 and 3 it like common, so common multiples. Now in this common multiples, sir, let us take 2 is not here and here is not there, 4, no 6. If you extend you'll get some other numbers. After 8 you'll get 10, 12 also. So 12 is here and here, 12, so on. So these are the common multiples, factor and multiple. So common factor and common multiples. Now let us see the briefly about HCF and LCM. So it's okay, it's printing. Now LCM. So the full form is least common multiple. Least common multiple. Now there are two methods to find out LCM. One is factorization method, one is a shortcut method. Now common multiples are there, in that least one is nothing but LCM. But every number to find out all the multiples and in that common, it's very hard. So instead of that, we'll find this LCM by two methods. So let us solve these two methods: factorization method and shortcut method. Okay, factorization method we'll see first. Let me take one simple example. LCM of 60, 24 and 45. Same example, I'll explain both methods. Find the LCM, that is least common multiple, of 60, 24, 45. For these three numbers we need to find out LCM. So for 60 we have multiples, 24 also multiples, 45 also multiples. In these multiples the common and in that least, that we need to find out using factorization method. Okay, in the solution, first we have to factorize every number. So here is given numbers are 60, 24 and 45. 60 I am taking, so divisible to 30. So 60 we can write 2 to the power 2 into 3 to the power 1 into 5 to the power 1. Then 24, same 2 table, 2 12s are 24, 2 6 are 2 3s and 3 1s are. So 24 we can write 2 to the power 3 into 3 to the power 1. Then 45. 45 is in 3 table, 3 1s are 3, 5s are 15. Again 3 5s are 15 and 5 1s are 5. Okay, 3 power 2 and 5 power 1. 45. 3 to the power 2 into 5 to the power 1. Fine. So after making in this prime factorization notation, then we can find out the LCM. LCM is least common multiples, not factors. So multiples means you can take the highest in this. Now here 2 power 2 and 2 power 3. So here is no 2 to the power, but the highest one is 2 power 3. Next 3 power 1, 3 power 1 and 3 power 2. So from all the numbers, the highest power we should take. Now 3 power 1, 3 power 1, 3 power 2. So 3 to the power 2. Then 5 to the power 1 is now 5 power 5 to the power 1. Now from this 5 to the power 1. This if you simplify, you'll get LCM. 2 to the power 3 is 8, 3 to the power 2 is 9 and 5. 8 into 9 into 5, that is 360. So 360 is the LCM of 60, 24 and 45. Only the thing is we need to take the maximum power, the same base throughout these three, which is the maximum power that we should take. 2 power 2, 2 power 3. So here is nothing means we can imagine like 2 power 0, because any number to the power 0 is 1. We can adjust 2 power 0. 2 power 0 is 1 only. So highest one is 2 power 3. Then in 3 to the power 1, 3 power 1, 3 power 2. So highest is 3 power 2. Then next to 5. Highest is 5 power 1 itself. That is the 360 is LCM. Now let us see the same question in shortcut method. Okay, the same question I'm taking 60, 24 and 45. So in this shortcut method, 60, 24, 45. So we should just do have to take the division 60, 24, 45. Any common factors are there, with that you have to divide. Now 60, 24, 45 we can divide by 3 table. 320 is a 60 and 24 is 380. 24 and 45 is 315. 28 and 15. At least two numbers you should take divide. Now I am taking 2 because 20 and 8 are divisible by 8. 2 tens are 20 and 2 fours are 8. 15 is not possible, so write 15 itself. As it is 15 right. Again 2. 2 fives are 10, 2 twos are 4 and 15 is as it is. Then again 5 and 15 are there, so both are in 5 table. 5 ones are 2 as it is if it is not divisible, and this is 5 threes are 15. So 2 and 3. Now except 2, 3 there is no any other common. They can stop that. Then LCM is these all numbers you should multiply. After finishing like this 3, 2, 2, 5, 1, 2, 3. This complete line you have to multiply as it is like this. Just multiplication. That is 3 into 2 into 2 into 5 into 2 into 3. You will get 3 to the 6, 6 to the 12, 12 by the 60, 62 is a 120, 3 is a 360. Yes. So 360 will get even in shortcut method. So shortcut method is easy. Just we should know the division and we should know some tables, proper tables perfectly. Fine. Now you see the HCF. HCF. So this is highest common factor. Highest common factor. Fine. So this HCF of two or more numbers is the greatest number which divides each of them exactly. Now I'll explain the definition. Otherwise, sometimes HCF is also known as the greatest common measure, like GCM, or so don't get confused from examination point of view. We can call it as some books or some question papers will give GCM. That is greatest common measure or greatest common divisor, GCD. Greatest common divisor. Divisor or factor both are same. Instead of highest, they'll use greatest. Okay, greatest common divisor. Greatest common multiple. Greatest common measure. So these are all come under GCD. Greatest common measure or greatest common multiple also you can take. Okay, whatever it is. Now highest common factor we'll have to find out here. This also can be done by using two methods, same like factorization method and division method. First let us see the factorization method. So same example I'll take like previous question. Find HCF of let us take the same example previous, that is 60, 24 and 45. 60, 24 and 45. So when I did prime factorization, 60 for 60 I got same we did previous, right? 2 power 2 we did previous. for 60, 2 power 2, 3 power 1, 5 power 1. 45 for 24. There is 2 power 3 into 3. 2 power 3 into 3 to the power 1. Then 45, 3 power 2 into 5 power 1. 3 power 2 into 5 to the power 1. So after writing in prime factorization notation, to find out HCF for this, we should take the least powers in this. So lowest power value should take. But that too should be in all the terms. No, not like LCM. Here 2 power 2, 2 power 3. So here again no more 2 powers. So we will not take anything. So that means if nothing is there, we will just consider like 2 power 0. Okay, this is 2 to the power 0. So least one is 2 power 0 only. Now 3 power 1, 3 power 1, 3 power 2. The least one is 3 power 1. And here 5 to the power 0. Because for any number power 0 is 1. A to the power 0 is equal to 1. Any number to the power 0 is 1. So value will not change. Then this is 5 to the power 0. That means this is 1 into 3 into 1. So 3 will get. That means the number, the base should be in all the terms. I mean every number. Then only in that power the least one will take. So 3 is the HCF for this. Let us see the division method of this. Same question we'll do in division method. Division method is shortcut method. That is important. And big numbers also we can solve easy. 60, 24 and 45. The question is 60, 24 and 45. First we will take any two of them. So any two you take. Now take the big number middle and divide with small number 24. So if they'll give 3, you should take only 2. Now I am taking first 2. With big number, small number you should divide. That is 24 table directly 60. So 24 into 2, 48. 24 into 3, 72. So it's more than that. Therefore 24 2s are 48. Then subtraction, there is a 12. Now again you keep a box like this. Now whatever this 24 you should write in this place. Okay, now this 24 we can write here. So divisor becomes again dividend. Then 12 table. Now forget about this part, previous one. Now 12 2s are 24. Once you get remainder 0, then this is the HCF. The previous, once you get 0, then divisor is HCF, that particular division. Then with this 12 you should do again 45. Now 12 is the answer for first both. With that next number is 45. So always small number you do division. Here 12 table complete 45. 12 3s are 36 because 12 4s are 48, right? So 45 minus 36 is 9. Again this 12 should be in this place. 9 table. 9 1s are 9. 3. Same procedure. Again this 9 should be next place. Again this 9 we can write right here. So 3 3s are 9. Once you get 0, Now this is the place is HCF. So just to divide that place, the last division in divide that place is HCF. Now 3 is HCF. Let us take some big number. Find the HCF. Same division method I explain. Find HCF of 595, 1071. Now for this number we need to do division. Okay, let me take 1071 should divide by 595. So complete 595 table. 1071 ones are because 2's it will be more than 1071. 595. Then if you do subtraction this 674, so 476. Fine. Again you have to continue this division. Again that 595 should write in this place. This one should be again like dividend. Every time divisor becomes dividend. Again 476 ones are 476. If you subtract 119, 9, 8 minus 7, 4 minus 1, 19. Okay, let us continue the same process. Same, what number should write now? This 476. 476 must be here. Then 119 table. So 119 4s are 476. Direct table. So exactly 476 come, remainder 0. Then finally 119 is HCF. 119. So answer is 119. 119 is the HCF of 595 and 1071. Okay, this is the division method. Let us see the one more question. One more. Now we'll find HCF of, yeah, one more question I'll explain you. Find the HCF of, because division method is important. So I'm briefly explaining with one more example. 13,281 and 15,844. Because whenever the numbers are very big, then this division method only is easy. Instead of doing the factorization method, this will plenty of time it takes, and we should find out the factors factorization process. Now big number 15,000. How much it is? 15,844. 15,844 divide by 13,281. So 15,000 change and this 13,000 change. Surely ones are 13,281. Then after subtraction we'll get 4 minus 1 is 3. 14 minus 8. So we'll get 256, right? Yeah. 2563. Continue the division process and that 13,281 right here. 2,563 ones are 2, so it will come 5, because 6 8 will be more. 12 8 15. Then 11 minus 5 6. 7 minus 1 is 6. Then 12 minus 8 is 4. Continue the same process. Now what you should write? This 2563. 2563 must write here. You can imagine 400 and this is a 2000 change. So compulsorily 4 5 is a 20. So 405 is a 20 hundreds. But it's 466 now, right? We will see 5 table. 5 6 is a 30. 0. 5 6 is a 30. 2563 or 2330. If you subtract 233, then write 466 this value. So it's 2 is a 466. 0, right? So 233 is answer. Then HCF is equals to 233. So this is highest common factor. So there are some factors for 13,281 and 15,844. In this all the common factors, the highest common factor is 233. That is HCF. Fine. Now let us see some important points in HCF and okay, we'll see some questions here. This is the worksheet practice exercise. So see friends, now this worksheet of practice exercise and some other worksheets also you can directly download from this website. So in this website you can directly download including solutions. After seeing this theory part you can do the sums yourself. Let us see some sample questions which is easily already discussed. It's LCM of 24, 36 and 40. You can do any method, if you division method or factorization method. HCF of 306 and 234. Similar sums, right, which I explained like. Now HCF of, they already gave in factorization, 13th one, prime factorization notation are given, that you can find out answer. So HCF means the least power you should take. Let us see this one. Here 2 power 2, in next set 2 power 3, here 2 power 4. The least is 2 power 2. So it must be the second, third, fourth. Only third and fourth. 2 power 2 is there. Here and here. Next is 3 power 2. Again 3 power 2, 3 power 4. So least is 3 power 2. So here and here. Both options. Third and fourth. Next is 5 power 5. 5 power 2. Here only 5. So this is 5. Next, that much on. Next, no 7 is here in this first term. So 7 will not come. 11 is here but is not there. So only third one. In all the numbers which are the commons, in that the least power is HCF, highest power is the LCM. But LCM we can consider remaining also, because highest we are considering LCM. Okay, next one is whenever they will give fractions, LCM of 8 by 9, 10 by 27, 2 by 3, or HCF of 10 by 27, 2 by 3, 8 by 9. Okay, such type of questions how to solve. Now I'll explain the LCM and HCF of fractions. Let's see this. It's over. LCM and HCF of fractions. First, LCM of fractions. So it's very easy. So fractions, for example, let the fractions are some a by b, comma c by d. Fraction means some numerator and denominator. E by F. So these are the fractions. Then LCM is equal to LCM of numerators by HCF of denominators. LCM of numerators, that is ACE, divided by HCF of BDF. Now this is the LCM of fractions. Let us take some example. LCM of, okay, this example one I am taking. 8 by 9, 10 by 27, 8 by 9, 10 by 27, and 2 by 3. Now LCM of this. So according to formula, LCM of the numerators. So LCM of 8, 10, 2 by, and HCF of 9, 27, 3. So we'll separately find out 8, 10, 2 LCM and 9, 27, 3 HCF. So if you take division method, a shortcut method, there are 8, 10, 2. This is division method. Shortcut method of LCM. So 2 table, 2 4s, 2 5s and 2 1s. That's all. 4 5 no common table again. So 2 4s 8, 8 5s 40. 40 is LCM of 8, 10, 2. Then HCF of 9, 27 and 3. 9 and 27 division. 9 3 is a 27, 0. So 9 is HCF. With that 9, one more number is 3. Now 3 3 is a 9, 0. So now this is 3. So 40 by 3 is LCM of that. 40 divided by 3, second option. Next one is HCF. Once you know LCM formula, HCF also easy. HCF means for numerators we will apply HCF, for denominators we will use LCM. Okay, I'll write that. HCF of fractions, that means HCF of numerators. So HCF of numerators by LCM of denominators. Let us take this example. HCF of 10 by 27, 2 by 3. They give 10 by 27, 2 by 3, 8 by 9. So according to the formula, HCF of numerators. Numerators are 10, 2, 8 by LCM of denominators. 27, 3, 9. Fine. Then you can find out HCF for this. 10 to 8. 10 and 2. So 2 5 is a 10. Remainder you got 0. So 2 is answer. With 2 one more number is 8. Then 2 4 is 8, 0. So finally 2 is HCF. Fine. That is the 2 is HCF. Then LCM of 27, 3 and 9. Okay, division method you apply. 27, 3, 9. 3 table. 3 9s are 3 1s are 3 3s are. Again 3. 3 3s are 9. 1 has is 3 1s. So 3 3 3. 3 times. So 27. 2 by 27 is a HCF. 2 by 27. Yeah. So whenever they give fractions, we can use the same thing. One more rule. The LCM and HCF of two numbers are 2079 and 27 respectively. If one of them is 297, then find the second one. So I'll give you one important formula for this. Okay, now relation between HCF and LCM, that is. I'll give relation. Relation between LCM and HCF. The product of two numbers. For example, A comma B are two numbers. And AB LCM is, let us take L, HCF is H. A comma B are two numbers. LCM is equals to L you take and HCF is H. Then product of the two numbers is equal to HCF into LCM. Then the formula is A into B is equals to L into H. So A into B is equals to L into H. That means product of two numbers is equal to HCF, their HCF into their LCM. So formula I can write like this. Product of two numbers is equals to their HCF into their LCM. So these two we can take. Now according to our question, LCM and HCF of two numbers are this and one of them. So LCM is this and HCF is this. So 2097 into 27 is equal to 297 into B. The B number you can find out. Therefore, the two numbers are 2079 into 27, one more number. So this product should be equals to, one of them is 297 into another number you have to find out. Another number you take some B. Then 2079 into 27 by 297. So if you simplify this, we'll get the value for that, so which is given. So we can find out that we can do cancellation this, so we'll get 118 means. Multiply and divide, so 189 is LCF. Next we have some other type of questions here. The special one. These are the actually basics of HCF and LCM. There are some important 6 type of questions are there in this LCM and HCF. Especially like this. The largest number which divides 380, 510 and 7 leaves the same remainder in each case. So word problems I'll explain you in another